Okay, so we're going to look at transformations for these. And just kind of like the notes that you guys sort of just took are on what the graph looks like at the beginning. Alright, so whenever we started graphing quadratics, we would graph just y equals x squared first, and then we took it and we shifted it up, down, left, right. So that we're doing the same thing here with our sine and cosine functions. So, and we're not going to do a ton of graphing by hand on these. Maybe a little, but mostly we're going to just look at explaining what happens to the graph. So if I had something like this, x squared plus 3, that is a parabola that's translated up 3. Right? That just moves it up 3. That is a vertical shift. Let's see. Yeah, look at what I've got there for you. If I have x minus 5 right here, that is going to move to the right 5. That is a horizontal shift. Okay? Translations, move a function up, down, left, or right. So let's look first at a vertical shift. Okay? So if I have something like sine of x plus 1, that is just like the other functions. It's a sine function that's been moved up 1 unit. So what we call that with a trig function is the midline. The midline is the horizontal line that runs through the middle of the function. So in that one that we just graphed, that midline there is the x-axis. And I think I have that here. So for f of x equals sine x, the midline is the x-axis. And also for cosine, right? But if we have a plus 1 at the end, that's going to move our midline up that much. Or if we have a minus 7, it's going to move it down 7. It's pretty simple to do those. A horizontal shift is whenever we have a number inside of the parentheses. So the horizontal shift, like in this case, if you had cosine of x plus pi, that's cosine shifted to the left pi units. For trig functions, you may want to underline this right here. We call the horizontal shift the phase shift. Because if we shift a trig function, sometimes it's hard to tell that it's actually been shifted because it just repeats itself over and over and over and over again. Right? So it goes on forever either way. So it shifts what phase you're in. If you think of like phases of the moon, right? The phases of the moon, if we slide it left or right, you're in a different phase of the moon, but it's just going to keep repeating over and over. Horizontal shifts can be really simple, like this one here, where you just move left pi, but whenever we have a horizontal expansion or compression, they get a little complicated. So we're going to learn more at the end of the section about those. Okay? So expansions and compressions. A little bit of review. If I have a number on the outside like this, that is a vertical expansion. If I have a number that's between 0 and 1 on the outside, that is going to be a vertical compression. If I have a number on the inside, and I don't really know why I chose to put a negative there. It would be the same if it was positive. That negative reflects. That is a horizontal compression. Remember, everything on the inside of the parentheses is backwards. So if you have a big number like 2, it's going to make the graph smaller, compressed. If we have a number like 0.5, and again, that negative doesn't really have to be there. It's a reflection, and I should have just left it off. That's a horizontal expansion. So a small number makes the graph bigger, horizontal expansion. Okay? So the vertical expansions or compressions are, in my opinion, the easiest thing to do for a trig function. The vertical expansions and compressions are going to give you the amplitude of the graph. The amplitude is the distance from the midline to the maximum of a trig function. So if you think of graphing sine, like we had graphed here, right? The distance from the midline to that maximum point, that distance was 1. Right, so you had an amplitude of 1. The amplitude of a function is just the number in front of, that's multiplied in front of the function. Just whatever you're multiplying by. So, like, for example, here, if I have y equals 3 sine x, my amplitude is 3. So that means rather than having a maximum at 1, I would have a maximum at 3. It stretches that graph to make it taller. And I really could say that it's also the distance from the midline to the minimum point as well. Either one there. So for y equals 1/2 sine x, my amplitude would be 1/2. Alright, Matt, for the last one, y equals 130 sine x, what's my amplitude? 130. Alright, just the number there in front of the x. Okay? So I think amplitude is one of the easiest things to find. I think midline is second easiest. Okay? Questions so far? Alright. So, if we have, I'm going to actually exit this real quick. If we have a graph y equals a times cosine x. Let me just show you what it looks like here. Add that slider. Okay, so like right here is my a times cosine x. What I just did there, if I make that number bigger, it makes my waves bigger, right? If I make that number smaller, it makes them smaller. If they eventually get to negative, it'll flip it upside down, right? So those flips still occur. But that amplitude tells you how far it is from the midline up to that highest point. Look what happens if instead of doing a vertical expansion or compression, I do a horizontal. So I'm going to put a right here. Ooh, let's make it back to just 1. So right here it's just 1. But if I make that number bigger, it squishes the graph in. Think of like an accordion that you're squishing in this way, right? If I make the graph smaller, it stretches it out. Well, I made it, hold on. Make it smaller, it's going to stretch it out. Eventually, right here, I got to the negatives, which made it look like it was starting to go back in. But if I just stop right here, it stretches it out. So if you think like a slinky or an accordion or something, when you pull it apart, those waves are going to get further apart. Whenever you squish it in, they're going to be closer together. So that's what we're looking at when we have these. So if I normally, my period for one of these, let me fix this here. Let's go up 5. Let's go negative 2 pi. 2 pi. Let's go 5 pi over 2. And we just need like negative 2. Okay, that's a better graph. So, like right here, if I look at this graph, this looks like when we graphed cosine earlier, right? So right now, we have a period of 2 pi. Because to get from a maximum point to the next maximum point, it's 2 pi. And then it just starts to repeat over and over. But if I make that number bigger, it squishes the graph in, right? Which means now that the period, if I look at this right here, what's the period of this graph? How long does it take before the graph starts to repeat itself over again? It's just pi now, right? And so if I make that number bigger and bigger and bigger, the period gets smaller and smaller and smaller because it's repeating more quickly. Right? Whereas if I make the number smaller, to be careful not to go to the negatives here. So if I make the graph smaller, it gets stretched out to where really I'd have to zoom out some there to even be able to tell really what the period is. Like here, you're talking about like from right here to right here. A much longer period there. So let's learn how to do that without graphing it. To find the period of a graph, you're going to do this right here, 2 pi divided by k. So if you remember, whenever we were doing horizontal expansions or compressions, everything on the inside, that factor was 1 over that whatever value you had there. So here it's not 1 over, but 2 pi over, because 2 pi is your normal period for sine and cosine. So, for example here, if I have sine of 5x, my period is 2 pi divided by 5. And if I have cosine of 1/2 x, then I would have to do 2 pi divided by 1/2. Now, typically, I do not like to leave something with a complex fraction. So, dividing fractions is easy as pi. Flip the second and multiply. And so, 2 pi times 2 over 1 is going to give us 4 pi. And it should kind of make sense if you have a 1/2, that's an expansion. If you stretch it out, the period's going to be longer. The 5, that's a compression. If you squish it in, then the period's going to be shorter. Okay, questions? All right. Now, phase shifts can be very simple unless you have a period change as well with your phase shift. So, if your period is not 2 pi, it affects your phase shift. So, for example, if I have y equals sine of k times x plus c, there's a phase shift of c over k. Okay? So, like, to give you an example where it would not be the case, like if I have sine of x plus 2, that is just to the left 2. But if I have sine of 3x plus 2, this is no longer left 2. This would be left 2/3. You have to divide by that number in front of your 3, or number in front of your x. And really right here, you could do the same thing. You're doing 2 divided by the 1 that's right here. It still equals 2, right? Divided by 1. So if I had y equals cosine of 2x plus pi, then y equals cosine of 2x plus pi, that is going to be to the left pi over 2, because you'll take this number here and divide it by this number here. Okay, questions? Okay. Alright, so let's do a few examples where we have to tell everything. So we want to know the period, the amplitude, the phase shift, and the vertical shift for each function. So if I look at number 1, the period. And actually, let me do this. I think this is helpful. I really should. I'm going to go back. Let me add something in here. This is not, you don't have this slide, but I'm going to, wait, hold on. Let me type this right here in. Or I'm just going to write it in. Somewhere there, I want you to write this. Let's do y equals a times sine of bx plus c plus d. You don't always have all of those numbers, a, b, c, and d, but whatever you have is going to apply here. So the period of a function is going to be 2 pi over b. So 2 pi divided by that number right there in front of the x is your period every time for sine or cosine. The amplitude is just a. Now, I will say this, amplitude is always positive. So I guess I might really should put absolute value back. It's always positive. If you have a negative there, that negative is reflecting it. The negative isn't part of the amplitude. So amplitude should always be positive. So that A is your amplitude. Your midline is always going to be at y equals d. So this d you have right here is your midline. That's your vertical shift, however much it's moved up or down. And then lastly, the phase shift is going to be C over B. So the C that you have right there divided by the B that you have right here. And phase shift, just like horizontal shifts, it's opposite direction. Okay, so let's look at some examples now. Okay, so for example 1, let's first, if we think about what we just did, we've got y equals 3 cosine of x plus 4. All right, our period is 2 pi divided by the number in front of our x. So we have the number in front of our x. We do not, so the period is just 2 pi. The number there would be a 1 if we had it. Okay, Lakin, what would the amplitude be for that problem? 3. Good. Let's see. Emily Lane, what's the midline? 4. So y equals 4. And then our phase shift, we do not have any numbers added on the inside of our parentheses. So we have no phase shift. So we'll just put 9. Or you can put 0. Okay. Now, you always have a period, amplitude, and midline. You will always have those 3. The phase shift you may or may not have. But the other 3 you always have. Because even if the graph is not shifted up or down, it still has a midline. Even if it's not stretched out or shrunk, it still has an amplitude. So you will always have the first three. Okay, so let's look at the second one. Hannah, what's the period for the second one? It's 2 pi. If it was going to be changed, it would be changed by the number in front of that x right there, but you don't have a number in front of that x. So it's just 2 pi. Nathan, what's the amplitude? Very good. Now, I just said the first three you always have. So midline, we have one. It kind of looks like we don't, but it is 0. Because the midline is the x-axis, which is y equals 0. So if it hasn't been shifted up or down, it's still y equals 0. So make sure you would never put none for the midline. You would put y equals 0 if it's not been shifted up or down. And then the last one, our phase shift. Allie, what's our phase shift? Good. Well, actually no. Almost good. Whenever we have that negative in there, everything on the inside is the opposite direction. So they're generally going to tell you that it's positive 3, or they might say right 3. Sometimes they just use a positive or a negative for their direction. So in this case, they would just use a positive 3. Or they might give you the direction written out in words. All right. Okay. Questions? All right, let's do a couple more. These next two are a little bit more complicated. Okay. All right, so Jaden, for number 3, what's the period going to be? Very good. 2 pi over 2, which is just going to give us pi. Sydney, what's the amplitude for that one? 2. Very good. Let's see, what else? Midline. Matt, what's the midline for this one? Is not 4. Because that 4 is inside of the parentheses. So it moves it left or right. If the parentheses ended right here, it would be 4. But it's inside the... Not work. But if it were inside of those if it were not inside of those parentheses, it'd be 4. But whenever we're really looking at what's out here and we don't have anything, so what's it going to be, Matt? 0. Good. And Caroline, what is the phase shift for this one? It's going to be 2, because we will take 4 divided by 2, right? So we take this number here, the 4, and we divide it by the 2. And that gives us 2. Is it going to go to the left or to the right, Caroline? Left. Opposite direction. So if you have a plus 4, it's left 4. If you have a minus 4, it's right 4. Or you may see this given as negative 2, depending on how they work out the key. All right, questions? All right. Savannah, what's the period for number 4? Very good. Just 2 pi divided by that number in front of the x. Liliana, what's the amplitude? It is not 0. It is 1. All right. There's no number out here, so if there was a number, it'd have to be 1. So you always have an amplitude. If there's no number there, it is a 1. Okay? Midline. Gabby, what's our midline for this one? Very good. And let's see, phase shift. Beth, what's the phase shift going to be on that one? No. I think you may have just divided wrong, though. It's going to be, what is it, Nathan? It's 2. You're going to do 6 over 3, which is going to be 2, right? And so I think you probably just divided that one wrong. And that will be to the right. Okay? Questions here? All right. I'm not going to actually, you don't have, okay. All right. So what we're going to do next is we're going to write an equation that has these characteristics. So, and we're actually not going to graph those by hand, so we won't do those last couple slides. But, so if we want a sine function with an amplitude of 4, a period of 2 pi, a phase shift of -2, and no vertical shift, or it might, sometimes they'll say midline, is that y equals 1. Okay? So if we want to do this, we're going to just start with y equals sine of x. Right? If my amplitude is 4, that tells me to put a 4 out here in front of our sine. My period is 2 pi. That is the normal period for pi, right? So do I need a number here in front of my x? I do not. I'm going to actually, well, I got the giant eraser. I'm going to slide that over a little bit there. So my x is here. I have a phase shift of -2, meaning left 2. So if my phase shift is -2, what would I have in the parentheses here? +2. And it's pretty simple here because I did not have a change in the period. So it's not confusing on what we need to do there. We'll just put the +2. And I do not have a vertical shift, or actually I should say my midline is 0. So my midline doesn't change, so I don't add anything else to the end. So this would be my equation. Y equals 4 sine of x plus 2. Now, I think the second one is a lot harder. Parts of it are still really easy. So we're going to start off with y equals, and we'll have cosine of, I'm going to put x, I'm going to put a lot of space there in my parentheses because I know I'm going to have to put something there. My amplitude is 1/2, so I'm just going to slap a 1/2 out front. I think that is the easiest to do, so we've taken care of that. I think the second easiest to do is the midline, or that vertical shift. So this has a vertical shift of 3. To do a vertical shift of 3 or a midline at 3, I just put a +3 over there on the end. Okay, so those two parts I don't think are too bad to deal with. Phase shift can be easy like the last problem, but in this case I think it's a little bit harder. Okay, so my period should be pi. Now to find period, I got to do 2 pi over, I'm going to call that b right there. All right, what number do I need to have for that b? I need to have a 2. I've got the giant eraser. We'll work on this one. I'm going to just mark it out and put a 2 there. That's kind of ugly. All right, I'll rewrite it pretty when I finish. Now, so that gives me 2. I have to get a phase shift of 1, but I'm not just going to put like a -1 here, because if I do, then that really gives me a phase shift of 1 over 2. So what number do I need there instead? 2, right? 2 over 2 would give me 1. So my equation here would be y equals 1/2 cosine of 2x minus 2 plus 3. So you got to be a little more careful whenever you have those. All right, we are not going to graph by hand, so we're going to skip this last part. And you guys have been very attentive today, and I have made you take notes for a long time, 2 days in a row. So we'll do the assignment we'll work on this Monday. So, no homework, except, now don't be letting this get out, because my teacher superlative was most likely to give homework on the weekend. I don't want to lose my title. I'm not going to require it as homework, but don't forget I'll put up that practice quiz so you can look over that this weekend. I'm not going to check it as a homework grade, but you can work on that. Yes. Yes. If it's negative, you want to add 2 pi instead. Yeah, so if you've got like negative 11 pi over 3, then you'll add 2 pi. Yeah. Same thing, if you have a negative degree, add 360 instead. Oh.